In this brief video, we're going to look at modules, packages and classes, how to create them and use them. This is in preparation for the next and final compulsory video of this week on the NumPy matrix library. Please open Notebook 1.3. So a module is essentially the name for a Python file which contains a group of related functions or classes used to perform an aligned set of routines. Python files are indicated by the file ending .py. Let's create one and populate it with a very simple series of math functions, as shown here. Start by opening Spider and creating a new file which we can save as the module simplemath.py. We're then going to populate it with these simple functions. And saving it again. Now what we want to do is create a new file which is going to use this module. Let's save it. The first thing we need to do is import the module we just created. Where in this first example, I'm going to give the module the shorthand prefix of SM. This now allows me to access functions from the module using the prefix. And then if I run this script that I've created, it prints out the number 5 as expected. Note, in order for this to work, it's essential that the module is in the same directory as the file, or, and this is generally better practice, that the module is in the Python system path. Also note that you don't have to import the whole module. You can choose to import specific functions. For example, if we use this syntax from Simple Math, import, then we can access the functions from the module without having to use any prefix. If we run it again, it gives 3 as expected. If we wanted to import all the functions from the module but not use a prefix, then we can do it with the following syntax. And this means we can also print out So this is how you import and use modules and create modules of your own. However, at this stage it may also be worth highlighting some of the standard modules that come with the Python package. These include the OS module, which performs operations on file names and allows accessing of the file system. For example, you can use it to create full paths combining directories and individual path names and check whether files exist. Also sys, so this allows the addition or removal of paths from your system, such that if you add some directory to your path, then you're going to be able to find files or specifically modules that are located at that path. Math is Python's standard math library for operations including rounding, taking numbers to the power, estimating the natural log. Argparse, so this allows us to create Python scripts that we can run from command lines. As an example of this, here's a code snippet from one of my programs, which runs a machine learning method called random forests, which you will learn about in week 7. The first 3 lines after the constructor, this is the constructor, reference arguments that are compulsory. The rest of the arguments starting with double dashes are optional, and it's possible to give them default values, for example, as shown here. After these lines, which define all of the arguments, we have a line which creates the object args, which passes the command line and saves all the arguments. You can then go on to use them throughout the rest of your code using this syntax, where you call args followed by the variable, where the variable's name is as described in the parser. And finally, random is a random number generator, where here you have random integers, and in this example it generates random floats between 0 and 1. Moving on to classes, these are slightly more sophisticated than modules as they support object-oriented programming and inheritance, limiting unnecessary repetition of code. The syntax for declaring a class is as follows, where my class is the class name, finishing with a colon. The first code in any Python class is the class constructor init, where here the first argument is always self, which is a reference to the instance being constructed. This is then followed by all other functions describing methods for that class of objects. When importing classes into your Python program, you must create an instance of the class using the following syntax. Then, if you subsequently want to call one of the functions from the class, you can do it in the following way. We're not going to be requiring you to create your own Python classes, but it's worth being aware of them, as you will call instances of different classes when you use Python machine learning packages. Packages are collections of classes and modules designed to solve a range of related tasks. And over the next couple of weeks, we're going to learn about a few different relevant packages, including a matrix library, the machine learning library scikit-learn, a plotting library matplotlib, and you have the option of looking into the pandas library, which is a very effective package for manipulating spreadsheet-like objects. Using Anaconda, the majority of Python packages you will need will be pre-installed. However, if you ever find one unavailable, you have 2 choices. You can either install via Anaconda using conda install, or you can use the pip install program. Don't forget to cite the packages if you use them in your projects. So, in conclusion, modules are .py files with groups of related functions that you want to call from other scripts. Classes contain collections of routines which describe the properties or behavior of a specific object or method. Packages are collections of related classes and modules, so it's getting increasingly more sophisticated. All Python modules, classes and scripts are written in .py files, and to use them you need to use the import syntax, and you must be sure that the module or class is either in the same folder or in your Python system path. So this is the end of this section. Please run through this very quick Keats quiz and then move on to the next and final compulsory lecture on the NumPy package.